We're on lesson 4 of chapter 3 today. We're looking at operating with scientific notation. One thing to remember before we begin, there's all these different ways of showing the same number when you're using scientific notation. We have 1,310 times 10 to the third. We have 0.0131 times 10 to the eighth. These are all the same number, but the one right here is the one that is correct, that is accepted by people in the scientific and mathematic community. 1.31 times 10 to the 6th, whenever you have 1 in the ones place or any number in the ones place followed by your decimal numbers. That is the correct method. So this is the correct way of showing 1.31 times 10 to the 6th, which would be 1310000. So that's the correct way of showing this number. This is important because as we're writing our answers here, we have to show the correct number. We have to show it correctly in scientific notation. A lot of times we're going to get answers like this, and we have to adjust it to this by moving the decimal over and changing this number. So here we have 4.5 times 10 to the 13th times 3.5 times 10 to the second. We have done this before, where we've done 10 to the 13th times 10 to the second, and we've done multiplying with decimals before too. And that's the strategy to use for this. We can do the times 10 to the 13th times the times 10 to the second. And we can do the powers first, then we can do these later, and then put them together and get our answer. So we could do 10 to the 13th times 10 to the second. And when you're multiplying powers, we usually just add those numbers, right? So 10 to the 13th times 10 to the second would give us 10 to the 15th. So we're going to write 10 to the 15th and kind of put that off to the side as we multiply our decimal now. Okay, that's supposed to be a 5. So we have 4.5 times 3.5, so we could take our calculator out and do that. It gives us 15.75, so we write our answer in here then. So 15.75 times 10 to the 15th. So now wait a minute, look what we showed before. This is the correct way of showing it. So this is kind of what we have now. We have 13.1. You have to move that decimal over 1 to give you 1.31, and then you see what you do? You raise that number because you moved it over to the left. So move that decimal over 1 and be 1.575, and we're doing times 10 to the 16th. So it's the same number, but this is the correct way of writing that number when we get it. And there's our answer. So now let's do it with dividing now. We have 4.84 times 10 to the negative 11th divided by 8.8 times 10 to the negative 4th. So let's do our powers first. So we have 10 to the negative 11th divided by 10 to the negative 4th. So we have negative 11. And when we do divided, we subtract, right? So minus negative 4. So whenever you have a minus and negative, it'd be a negative 11 plus 4. This is one of those positives versus negatives. Which one wins? The negatives win, right? By 7. So our answer would be negative 7. So our 10 power would be 2 times 10 to the negative 7. Now let's figure out the decimals. 4.84 divided by 8.8. Oops. So 0.55. So we have 0.55. So what do you see that's wrong? We have a 0 here, right? So what did we do before when we had that problem? We moved that decimal over to the right, and we dropped that number down 1. So we're going to do that again. Move that decimal over to the right. We have 5.5. Move this number down 1. That'd give us negative 8. Right? That's 1 smaller than negative 7. So it'd be 5.5 times 10 to the negative 8. And that would be our answer for that one. Let's move on to adding and subtracting then. With adding and subtracting, they're a little special. You know how like in fractions we have to find common denominators? Here we kind of have to find common powers to make it work. So what we could do is you can make this a negative 4, or you can make that a negative 5. Both would be acceptable. If we're going to make this a negative 4, that means we're going to make this one bigger, and it means we're going to make the decimal move over to the left. See that? It gets one bigger. You move the decimal over to the left. So let's do that to make that one negative 4. So it'd be 0.91 to the negative 4, then minus 4.9 times 10 to the negative 4. So we actually can do this with our calculator then. So 0.91 minus 4.9 gives you negative 3.99. And when you're subtracting these powers, it's kind of like subtracting fractions. The denominator stays the same. Same thing with these. The power stays the same when you subtract. So you need to follow that as well. So you just take the times 10 to the negative 4. Let me fix this here. So that's a negative right there. So there's our answer, negative 3.99 times 10 to the negative 4. This is actually incorrect. We don't have to fix this at all. Sometimes we do. So we have 5.3 times 10 to the 7th, 8 times 10 to the 5th. So we have to adjust one of these by 2. Let's say we raise this one by 2, the 8, huh? If we're going to raise that to 8 times 10 to the 7th, we have to move that decimal over twice this way. So it would be 0.08 times 10 to the 7th. And I could have gone the other way with this one and made that 530, but I just kept that as is. So I have 5.3 times 10 to the 7 plus 0.08 times 10 to the 7th. So we can add these together. So 5.3 plus 0.08, 5.38. All right, and since we have 5.38, I don't need to do any more adjusting, so this is just our answer, 5.38 times 10 to the 7th.